Hi everyone. Our topic for week 5 lab is database of AI tools, history and future. We are from group GW9 and we have chosen Kimi AI as our AI tool. I am Priyadeshini Yoeswaran and I'm going to walk you through the evolution of artificial intelligence. It's a journey that has moved from rigid logic to human-like creativity. We can break this history down into four distinct areas. Let's see the first era. We'll begin with symbolic AI, and it is also often called as the logic based era. How it worked? It used a top down approach. Essentially, humans manually coded thousands of if then rules to tell the computer how to exactly think. This era was famous for expert systems. There were programs designed to mimic specialists like doctors to help with things like medical diagnosis. However, these systems were very brittle because they couldn't learn on their own and they often crash or fail if they encountered a situation that wasn't explicitly written in their code. By the 1990s, we saw a major shift toward machine learning. We moved to a bottom up approach. Instead of giving the computer rules, we gave it massive amounts of data and used statistics to let the computer find its own patterns. This era gave us the practical AI we use every day, like Netflix recommendations and email spam filters. This was a turning point because computers stopped just following manuals and actually began learning from the data provided to them. Around 2012, the field exploded with the rise of deep learning. This technology uses artificial neural networks, which are layers of math inspired by the way the human brain functions. This era mastered perception. It's the reason we now have highly accurate facial recognition, voice assistants like Siri, and autonomous driving. This wasn't just a math breakthrough. It was powered by the arrival of big data and the massive processing powers of GPU. Next, we are finally currently in the era of generative AI. This is powered by the transformer architecture, which allows AI to understand context and relationships with information. The goal has shifted from analyzing data to creating it. We also see this in tools like ChatGPT and Midjourney, which can generate original text, art, and code. Today, AI is becoming multimodal. It is no longer just a chatbot. It can see, hear, and speak to us simultaneously, making it a true creative collaborator. As you can see, AI has evolved from a machine that follows rules to a system that can create and interact with the world much like we do. Thank you for your time.
Hi, my name is Ejina Shafia binti Nur Azman, and today I will talk about the data foundation of Kimi AI. Database act as the memory of AI. They have a massive data storage. AI require billions of data points to learn. Database act as the warehouse where all big data is stored and organized. Next one, they have data structuring. Raw and messy information data such as text, image, and logs is cleaned and structured into a format that machine learning algorithms can actually process. And the last one, which is the scalability. Databases allow AI to grow by handling large and larger data sets without slowing down the training process. Next one about vector databases and long context support. Kimi AI doesn't just look for keywords, it uses vector databases to understand the meaning of prompt. This allows it to provide relevant answer based on context. And next one, Kimi AI handle massive 250 60K token window. Specialized databases quickly retrieve relevant chunks of information from long documents, allowing Kimi to remember details across hundreds of pages. And last one about retrieval augmented generation or RAG. Databases allow Kimi to access real-time external information. This open book approach ensures Kimi answers are factual and up to date, preventing AI from making things up, such as hallucination.
Kimi AI is built on a massive 1 trillion parameter transform architecture, but instead of using all parameters at once, it uses a smarter approach called Mixture of Expert (MOE), where only selected parts of the model are activated when needed. Next is the sparse activation. This, although the model is extremely large, only about 32 billion parameters are activated per token. This makes Kimi AI highly efficient, reducing computation while still maintaining strong performance. Another key innovation is its multi-head latent attention technology. This allows AI to process and remember information more efficiently, improving both speed and understanding. Kimi AI also support 256K context window, which means it can handle a very long conversation or document. At the same time, it achieves this with 50% less memory bandwidth, making it both powerful and resource efficient. Next is the side layer of Kimi AI. Kimi AI uses native resolution processing. This means it can understand image directly without converting them into text description. As a result, it avoids information loss and capture visual details more accurately. Second, it introduced a unified embedding space. This allows visual data and language to work together seamlessly. In simple terms, Kimi AI can see and read at the same time, improving understanding across different types of input. Another key feature is spatiotemporal analysis. This enables the AI to understand movement and context in videos, not just static images. It can analyze how things change over time, leading to more accurate interpretation. Finally, Kimi AI has a strong technical edge. It can precisely interpret complex diagrams, high frame rate videos, and detailed visual content, making it powerful for real-world application.
So next, I will continue with the parallel and adjunct swarm intelligence part. So, but how does this intelligence translate into action? So, from that, we shift from sequential processing to parallel agent swarm intelligence or PAR. Most AI tools solve problems linearly one step at a time. However, Kimi used a dynamic decomposition strategy to break complex monolithic problem into a smaller heterogeneous subtasks. It then orchestrated up to 100 parallel sub-agents to solve these tasks simultaneously, resulting in a verified 4.5 performance gain. This is further optimized by quantization-aware training in INT4. This means the model can perform high-speed inference without sacrificing the precision required for academic or professional research. We aren't just looking at a chatbot, we are looking at a coordinated swarm of intelligence. So this is what is parallel and agent swarm do and do in a Kimi AI. So next, I will continue with the strategic adaptability, which is the user experience. So lastly, I will explain about the adaptive architecture model modes, which is they have four modes. So the strategic adaptability, which is the user experience, it more focused on architectural scaling and human AI interaction. So finally, we conclude with how this architecture adapts to the user. Kimi core principle is dynamic scaling. It depending on the complexity of the prompt, the system scale its internal logic across four distinct pillars. Instant mode for low latency rapid fire responses. Thinking mode, which is provide transparent step by step reasoning, trust essential for verifying AI logic. So for agent mode is for sequential tool integration. And finally, agent swarm mode for peak parallel orchestration. This architecture flexibility ensure that Kimi isn't just a static tool, but a responsive agentic ecosystem that adapts its computational power to the difficulty of the task at hand. So that's all for me. Thank you.
In conclusion, artificial intelligence has become an inseparable part of modern life, delivering significant advantages while also presenting obstacles. Its future promises great advancement in the industries, scientific research, and everyday convenience. As AI continues to progress, prioritizing ethics and responsible application will be essential in creating a better future for society. Thank you.